So, hi guys. I think I'll start with the lecture now. It's quite late. And finally, there was electricity at my place. Or else I was like, what I'll do, I'll postpone it or I don't know. And finally, it came. Yeah. So, let's begin. Welcome all. Hi. Second day for this Rhino course. Okay. So, about today's brief, as it was mentioned in the brochure, that I'll start with understanding Rhino. So, it's about what is the interface of Rhino, that how can we start modeling, right? How can we start with modeling? Because when one is introduced to the software, how he or she can start with it. So I thought this is an essential one to go ahead. And I'm assuming that everyone has their Rhino installed. Rhino 5 or 6, it doesn't matter, but if installed, then yeah, we'll start modeling today only. I'm assuming I had planned that we'll start modeling today, and then it will help. Like today's course will help us to develop further models ahead, like for curves, surfaces, and solids. And yeah, understanding how the user face works. And yes, we'll start with modeling. I'll share my screen. And yeah. So what you can do is full screen. Yeah. So I was thinking that either you can split the screen and work simultaneously with me, or you can take notes, or at the end I'm giving few times so that everyone can just brush it up for today's course. Yeah, so this is the icon. Double clicking on it, it will open it, and soon it will start. No, with us. So this is the pop-up page that everyone can see. Now, yeah. So what I'll show it to you once again. This is an important one. When we click on new, it asks for the template, which template we want, like meters, millimeters, feet, inches, depends on how large the model you are making and what tolerances are there. When we hover on each of this icon, each of this text on the right hand side over here, it describes what that template will have. For example, large object feet. Use this template file for building the objects the size of truck or large units. So it gives a scale, reference, and also the tolerance. I prefer using large objects, millimeter. It says tolerance of 0.1. And yeah, we'll go with that. Hmm. So, sorry for this. Am I audible, guys?
Yes.
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 Okay.
Yeah.
Okay, so if there is any lag or any disturbance or anything, just pop it out. Yeah, because yesterday there was some and I didn't know that it was going. Or if I'm going too fast, then just buzz me up. Yeah. So this is how the Rhino interface looks like. And yeah, so it's everything all up there, what we want to work with. So I'll describe what each and every space is like. So at the top, we have the menu bar, which is over here. It's like whenever you go to have food at restaurant, they have menu, like what all stuff they have. So it's like same over here. Every software does. Yeah. So the menu, sorry. Can you see me, guys?
Yeah.
Yeah.
Oh, okay. I thought I just signed out.
Yeah.
Yeah. So this is the interface of Rhino. So at the top, we have the menu bar, as I mentioned. And then we have the history bar, which is this one. then the command prompt, the standard toolbar, the side toolbar, the 4 viewports, and how the screen came up. Guys, I will share once again my screen. So, yeah. Yep. So what I was saying, yeah, the standard toolbar, the side toolbar, and the panels over here. At the bottom, we can see over here is the status bar. So I go into brief, like not brief, but I'll go into detail for each and every of these bars because it's necessary to know while modeling how all they can assist us and where to go if you are modeling certain kind of geometry and all. So on the menu, we'll have everything. So say under surfaces, we want to create a plane, but how to create a plane? Say from corner to corner, a 3-point, or create a vertical plane. Or say there is some condition that we want to make planes through points, or say through cutting plane, or say so from a picture. Anything, it just pops it out at what are the conditions by which we can make the geometry. So for example, if I want to make curve, then what type of curve I want? I want an ellipse, then how the ellipse can be made. Hyperbola, then by what ways we can make hyperbola. From circle, then from what kind of circle we want, like how we can generate circle from which conditions, like either from points or radius or tangents. It goes, so this is like an important one. Whenever like I am stuck in, so for example, if I want to make solid, so what I do, I just go into solid. I see then what type of solid. I'll say a tube. Then I can go over there and start making it. And then, yeah, this was just a pretty, let's say a small step. Yeah. So this was about the menu bar. And then we have the history bar and the command prompt. So most of the softwares, like for example, people have used CAD, SketchUp, and even Revit as well, and many more, ArchiCAD and whatnot. So what they have like command prompt. So you type in any command that you have, for example, scale, typing scale, and then you hit enter. So then the command is activated, and then it goes on. So command prompt gives you suggestion. For example, I'll say I'll go with move. So I'll type the abbreviation initial M. It will show me all the commands that the Rhino has that starts with the alphabet M. And then I'll type second one O, then it will say O, V, E. But it's, yeah, so that's it. That was all about the command prompt. About the history bar, you can just drag it down. Yeah. So it shows us the entire history, that what all steps we had taken. For example, while modeling a complex geometry, or say even tiny detail for a screw, the grooves on the screw, anything. While doing that, if I've mentioned a radius for the particular command, or while filleting it or anything, and I want to know what that was, I can go into the history and check it, what commands I had used and what were the steps and all. And there is infinite number of undos, control Z, and then redos also control Y. It goes on infinite. You can go to the start and also from start to the end that way. So yeah, that was about the command and history, command and history bar. And then we'll go with the standard toolbar, which is below here. Even this has everything. It's similar to the menu bar, but I'll say it's quite user friendly because it has icons, which is like good to see rather than remembering I want to make a plane from 3 points or make a solid which is rectangle in shape and skewed at the top and all. Good to just go into this one. All the icons over here, it will help. So for example, print it, or say we go into visibility to hide some objects, show some objects. For example, in curve tool to make curves and all. So it is like really nicely organized for us to work with. That's why it's important to know how all those bars work. This was pretty much about the standard toolbar. On the left, we can see the same thing. For example, there are two things. One is creation, that is generating geometry, simple geometry, that is curves and all. You can see here line from tangent and all. And then there is editing work, for example, fillet, chamfer. It's utilities for all. Utilities that we are using for that one. For example, when I go into surface tools over here, it says the formation of surfaces and then working on the surfaces. Same goes for solid, formations of solids and then working with solids and all. So it's like generating and then doing additional work on it. So primary geometry and then its utilities. Same goes for mesh and rendering as well. For yeah, rendering as well. What you can do when you are here, you can use a scroll, and you don't need to go move your cursor. You just scroll it down, and then you can go into each and every one of it. Like this. So this was about the standard toolbars, and yes, and then the panels. So over here, at this part, we can see at the top, at the command prompt and all, we can see the commands and what actions we have taken. Over here, it's mostly about modeling, drafting, rendering and all. And over here, we can have the same with the panels, which is docked on the right. But there are like other components which are essential. For example, the properties, layers, renders, display. Uh, so there are two things that I'll say. One, to have always on the right, because it's good to see while you're modeling and then you can use this one. And second thing is always use property for checking your model, because sometimes modeling gets damaged, or because of not doing modeling in correct way, the model is not made properly. For example, once it happened to me that I was making model for 3D printing, and they were just really simple steps, but I didn't follow it at that time. I didn't know, and I wasn't using property. And while coordinating with the guy who was making the 3D printed model, he couldn't do it, and then later on I had to redo the entire model, even though it took time. But I'd say to use the property because it will help. Like while developing the model, it will help you. And also, second thing is layers. I'm aware that all of us over here have worked on layers, not in Rhino, but I'll say in AutoCAD or other software. So it's similar to that. You can make layers within it, like new layers. There is additional feature as well, which is like sub layer. So you can go into and make sub layer. And yeah, it's pretty good in that way. So you have like in Photoshop, we have sub layers. So it's similar to that, like a group, I'll say. And yeah, the next thing was the display or the display tab over here. So what it does when we are modeling, we don't want curves. Okay, so what I'll do, I explain this with modeling only. This I'll explain you later. Yeah. So next thing about is was how the Rhino geometry works, and why I said yesterday that Rhino is good. Like I feel that Rhino is good rather than SketchUp and other softwares. So I'll show you a quick example. So I'll delete this one. So I make a surface, change it, share it. I'm just making a wavy surface. Yeah, something like this. So the geometry that is built, any geometry apart from mesh, I'm saying any geometry, curves, surfaces, and solids, all falls under the knobs. All falls under the geometry called as knobs. I'll tell you what the it's an abbreviation as it is called. So it is called as non-uniform rational B-spline. I don't know such technicalities, but I just know the word spline. Uh, okay, so getting back to our course. Yeah, so all the geometries that are developed within Rhino, apart from mesh, are called as knobs. While there are other softwares, they work under meshes, uh, mesh-based polygons. So what I'll do, I'll convert this into mesh. Yeah. So these are, so on the left we see knobs, and on the right we see meshes. What are meshes? Meshes are made up of polygons. You can see the triangulation over here, and also we won't see the smoothness that we are achieving over here. When the light falls, we can see it's kind of a smooth surface. There is no facets, nothing. It's smoothened out. But over here, we can see that when the light is falling, because of the facets, it's not getting smooth. We can understand that it's not a smooth surface. See over here, like these are the facets that we see. That's why, like most of the renderers and all, they work on mesh. But what they do first, they make objects in Rhino or any knobs based software, and then they convert into mesh. For example, even in 3D printing, you require uh, a geometry which is built out of mesh, and that helps because that's the software that's running. And yeah, so as I was saying uh, about meshes, so that's the, I'll say, a negative point for the softwares that are using meshes. When in softwares like SketchUp, PC, like after we have smoothened all the curved extrusions, it doesn't work. But in Rhino, it's very easy. And then that's why I say it's good. What I'll do, I want you guys to work simultaneously with me. Just take this few boxes out. For example, this is so face creation, the curves, and then the solids. Yeah, seems like guys, I just have around 10 minutes or something on this video, but I'll organize one more after this one. I just want to finish it by 6. 20 minutes are there, but 10 minutes are running here. Let's send a new link as soon as this gets over. Yeah, so what I want you guys to take this 3 dialog boxes outside. One is over here at the curve, which is the fourth icon. Cascade it down and then pull it down. Then the surface creation, and then solid creation. These three are we'll be working in these three: curves, surface, and solids in the 3 upcoming courses. And for now, I'm just making simple geometry. I'm working with curves, make some surfaces. I want to show you how uh, we can use other attributes like layers, visibility, layers, visibility, and also and how layers can help. What I'm doing, I'm assuming even you all have made some of the geometries like such, and go into the properties section. Click on any of the objects that you have made. Say the object type is closed surface. Every time the surface or the solids, the volume has to be closed. If there are open surfaces, it will say the object is open. I'll open this one. So it's a poly surface. It says open poly surface. It's always good to have closed extrusions or closed poly surface. Unless it says closed solid poly surface. Same goes for cylinder. When we select on the curve, it says open curve. We can have closed curve too. Yeah, closed curve. The reason I'm saying every curves and solids should be closed is because we can generate uh, surfaces and we can extrude from closed surfaces. For example, curves and from solids as well. That's why I'm saying it has to be closed. Uh, yeah, coming back to it, talking about layers. Even though like I'm assuming I feel that it's going a bit difficult because it's the first time that you all are using the software. But I'll say you can ask a number of times. You can text me, you can WhatsApp me. Even though like we have our group and you can text me there, and I teach this once again. The reason I'm going a bit fast and introducing to use such complex terms is that Rhino is way too advanced for us to understand. Right now, I'm just touching the modeling aspect of it, but we have to go at this pace only. And I'll say, guys, practice because it will take time to learn. And within this 5 course, even though after this 45 minutes of lecture, you have to practice it. And even though like I had planned today, like I'll have 15 to 20 minutes with you guys, and you can just make random geometry compositions by using these three creations, and then we can go with it. Right now, it's just a planar geometry, but once we go into detail one, how to go ahead and how to make geometries in 3D planes, then it's going to be difficult, and I mean, then it will be difficult to work with. But I'm saying if you have any doubts, just text me. I'll resolve it for you. Okay, yeah. So then coming to visibility over here. This is an important one. While modeling complex geometries, I always prefer to use visibility because it helps me a lot. I go into isolate object. I just have this object and I can go work on it as in how I wanted to reverse it, I reverse it and work work ahead. And when we want everything, just show it, hide it, select it, and hide it. Apart from layers, we can do that. This visibility option works only for elements. I mean to say only for geometry, not for the layers. If you have assigned any layers to any geometry, like I'm saying change object layer, you switch off the layer, it goes off. You select the geometry by left click on it and go on the layers, right click and then say change object layer. Will change the object layer for you like this. I have selected with my left key of the mouse and then right click for the layer above here and then say change object layer. And also an important thing, what I was doing here, these are view styles. And one more thing that I want to explain, there is just, I say 2 minutes left. Okay, so one more thing is the view style. These are all the view styles that how you want the model to be viewed. For example, in wireframe, when I click on wireframe, I just see the edges of any solids. For example, the curve remains curved because it's a curve. Rest all of the model seems like wireframe. Only the edges are seen, nothing else. For the shaded one, we see the surface. So also there are two types of visibility for surface. When we go into display, there are surface iso curves and surface edges. You can play over here and understand how this goes. So surface iso curves are these ones. Iso curves are directions that are U and V. Just for right now, just understand that surface has two things for its formation. That's U direction and V direction. As we have X, Y, and Z coordinates to develop the geometry, we have U direction and V direction. When I switch it off, it should go, yeah, it goes away. Same, it goes for in the entire model. Surface edges are the edges of the geometry, and then tangent edges, it works for surfaces such as spheres and ellipse and all. This is this is how it's seen. You can see. And then coming again to view style, we can see rendered one over here. If you have applied any texture or color to your objects from layers or going into selecting a model, going into property and then applying a material over here, then you can see just apply one material. Let's say I'll apply gem. Yeah, something like this. And then there are other ones also. I would suggest you to try try all these over here. I'm sorry guys, it's 1 minute left. I'll do something. I'll text you up.